Okay, so 1.12 says calculate the relative atomic mass of an element from the relative abundance of its isotopes. So looking at isotopes here, so isotopes are atoms of the same element but with different number of neutrons. So here we have chlorine 35 and we have chlorine 37. So chlorine 35 has 18 neutrons and chlorine 37 has 20 neutrons. Now obviously they both have 17 protons, because otherwise it wouldn't be chlorine. Okay, so these isotopes are different. So isotopes of an element with more neutrons have a higher mass, a higher density, a higher melting and boiling point, and have a slower rate of diffusion. So they do differ in a certain extent, but they behave chemically because the electron configuration is what decides the reactivity. So chemically they behave the same. Okay, so calculate the relative atomic mass of an element from its relative abundances of its isotopes. So 75% of chlorine is chlorine 35 and 25% is chlorine 37. So looking back at our syllabus statements, we have to be able to calculate the relative atomic mass of an element from the relative abundances of its isotope. So 75%, so 75 times 35 plus 25 times 37 divided by 100. Okay, so let's work each. Okay, so 35 times 75 is 2625 and 25 times 37 is 925. So that gives us 3,550 divided by 100, which will equal 335.50. So if you see on the periodic table, so that's the relative atomic mass of chlorine. So you'll see it actually written down as chlorine 35.517. So this is the relative atomic mass of chlorine, because it's a combination of chlorine 35 and chlorine 37. So the difference between this number that has the fraction in it here, that is the decimal number, 35.50, is that is the average mass of the isotopes of chlorine. Whereas this chlorine 37 up here, we call this the mass number. So the mass number of chlorine at 37 is 37, and the mass number of chlorine 35 is 35. Okay? And this is how you calculate the relative atomic mass from the abundances of the isotopes.